I'm sorry for the interruption. So today we are working on the exercise 7C from the Pure Maths 1. This is about tangents and normals. The basic topic is differentiation. This is the episode number 2. This is the episode number 2 on this exercise, and we have already done one episode on it. This is question number 4 of this exercise. An equation is given: y is equals to 5 minus 3x minus 2x square, and we have to prove that the equation of the normal at the point minus 2 comma 3 is 5y plus x is equals to 13. Okay, so what we will do, we will take that curve's equation, y is equals to 5 minus 3x minus 2x square, and I will differentiate it. So when I will differentiate it, the derivative of the 5 is 0, derivative of the minus 3x is minus 3, derivative of the minus 2x square will be minus 2 into 2 into x. So the derivative will become minus 3 minus 4x. So at the point minus 2 comma 3, so in the derivative at the place of the x, I will substitute minus 2. So dy by dx will be equals to minus 3 into minus 4 into minus 2. So this will become minus 3 plus 8, and that is 5, positive 5. That is the equation of the tangent, the gradient of the tangent. So if we want to find out the gradient of the normal, we will reciprocate it and we will change its sign. So the gradient of the normal will become minus 1 by 5. Now I will find the equation of the normal. The formula is y minus y1 equals to m bracket x minus x1. So y minus y1 is 3. So it will become y minus 3 equals to minus 1 by 5 bracket start x minus minus 2 bracket close. So this will become y minus 3 is equals to minus 1 by 5 bracket x plus 2. So 5, I will take it to the other side. It will multiply with the y and the minus 3. So it will become 5y minus 15 equals to minus 1 will multiply with that bracket. So it will become minus x minus 2. So take this minus x to the other side, bring that minus 15 to this side. So you will have 5y plus x equals to 13. And this is the A part of the question number 4. We have to prove that the equation of the normal is 5y plus x equals to 13. Okay, so now we are moving to the B part of the question number 4. It says, find the coordinates of the points at which the normal meets the curve again. So this is the equation of the normal. So the equation of the normal is 5y plus x is equals to 13. And the equation of the curve is y is equals to, this is the equation of the normal, and this is the equation of the curve. We have to find out the point of intersection of these two with each other. So it's very simple. What we will do, we will solve this equation and this equation of the curve simultaneously. So in the place of the y here, I will put this value, y equals to 5 minus 3x minus 2x square. So I will put this y value in this, substitute this value here in the place of the y. So you see what will happen. It will become 5 bracket 5 minus 3x minus 2x square bracket close plus x equals to, I am solving them simultaneously. Okay, so this will become 25 minus 15x minus 10x square plus x equals to 13. So minus 15x plus x, that's minus 14x. So I will take them to the other side. It will become 10x square. This will be minus 14x. When it will go to the other side, it will become plus 14x. And this is 20 plus 13. And this become minus 25 equal to 0. So you will have 10x square, and this is plus 14x, and 13, 7, 7, and 5, 12. So minus 12 equals 0. Divide it with the 2. So you will have 5x square plus 7x minus 6 equals to 0. So when you multiply the 5x square with the minus 6, you get minus 30. So I will do the midterm breaking. You know the midterm breaking. So 5x square, this will become plus 10x minus 3x minus 6 is equal to 0. So wait. So I will take 5x common, x plus 2 minus 3 common, and x plus 2 equals to 0. So I will take x plus 2 common and 5x minus 3 equal to 0. So we will have x plus 2 equal to 0, x is equal to minus 2, 5x minus 3 equal to 0, 5x is equal to 3, x will be equal to 3 by 5. So I got the two values of the x, then I will put this value into the 5y. So I will put this value, sorry for the interruption, my kids came. Okay. I have to set this. Okay. Sorry for that. And I will put this value in this equation. So we will have 5y plus minus 2 equals to 13. So you will have 5y minus 2 equals to 13. So 5y, this 2 will add there, so it will become 15. So y will be 15 divided by 5, that is 3. So the coordinate is minus 2 comma 3. This is the point already given, okay? Then I will put this value, so 5y plus 3 by 5 will be equals to 13. So 5y will be equals to 13 minus 3 by 5. So I will take the, so 15, I will take the LCM 5. So 5 is a 15, 1, 5 1s are 5, 5, 65 minus 3. So the y will be equals to 65 minus 3, that is 62 divided by the 25. So the other point will be 3 by 5, comma. It will be 3 by 5, comma 62 by 25. Let me check that is the answer right. I hope that this is right. This is, he says it is 0.6. It's 0.6. Okay, let's check. 62 divided by 62 divided by, sorry, 3 divided by 5, that is 0.6. Okay. And 62 divided by 25, and that is 2.48. Their answer is also 2.48. Okay. So our answers are good, sir. So what we are going to do, this is how we do the question number 8. You see the space here is little smaller. So we have to write little in the smaller font. So I hope that this question is clear to you. In the A part, we have to find the coin of the normal. And in the B part, they ask us to find the point of intersection between that normal and that curve. So I took the equation of the normal and the equation of the curve, and I solved them simultaneously. So I found the two values of the x. These are the x coordinates of the point of intersection. There are 2 points of intersection. And once we know the points of intersection, then the x coordinates, then we put those x coordinates. You can put in the equation of the normal. You can also put them in the equation of the curve, and you can find the value of the y there. So we found that there are 2 points of intersection. One is minus 2 comma 3. That was already given in the question. The other point is 3 by 5 comma 62 by 25. So this is how you do the question number 4. And I hope that this is clear. Sorry for because my children were here, so one of them just pushed the tripod and it just. So we are going to do the next one. This is exercise 7C. Now I am going to attempt the question number. I will attempt the question number 5, and let's see what happens. Question number 5. So this is exercise 7C and 7C, and it's question number 5 I am going to attempt. Exercise 7C of the pure mathematics 1. We are working on the course book. Okay. So question number 5. The normal to the curve y equals to. Here an equation is given. They say that the y is equals to x cube minus 5x plus 3 at the point is also given here, at the point minus 1 comma 7 intersects the y-axis at the point P. This normal, the normal to the curve, the normal cut y-axis at point P. So we have to find out the coordinates of the point P. Listen carefully so we make sure that I have not written any sign by mistake. Sometimes what happens, we note down the signs incorrectly. The normal to the curve y is equals to x cube minus 5x plus 3 at the point minus 1 comma 7 intersects the y-axis at the point P. Find the coordinates of the point P. So very simple. So what I am going to do, I am going to first of all find the equation of the normal at the point minus 1 comma 7. So I will derivate this. This will become dy by the dx will be equals to 3x square minus 5 plus 0. So the dy by the dx will be equals to 3x square minus 5. So at x equals to minus 1, the dy by the dx will be equals to 3 into minus 1 and square minus 5. So this will become 3 minus 5, and that is minus 2. The gradient of normal will be 1 by 2. This is the gradient of the tangent. The gradient of the normal will be the reciprocal of this, and they will change the sign. Because the normal and the tangent, they are perpendicular to each other. So now we will find the equation of the normal. The formula is y minus y1 equals to m bracket x minus x1. So I'm going to use this point. So it is y minus 7 equals to 1 by 2 into the x minus x1 is minus 1. So this will become y minus 7 equals to 1 by 2 into x plus 1. Bring this 2 to this side. 2y minus 14 is equals to x plus 1. So 2y is equals to x. This will add there plus 15. So this is the equation of the normal. Okay. So now we have found the equation of the normal. They say that the normal cuts the y-axis. You see, whenever a line cuts the y-axis or curve cuts the y-axis, its x coordinate is 0. The x coordinate is 0. Okay. The question is, intersects the y-axis at the point P. Find the coordinates of the P. When the normal cut y-axis, x will be equal to 0. So in the equation of the normal, this is the equation of the normal, 2y equals to x plus 15. Put the x value 0. So 2y is equals to x plus 5. This is 15, sorry. And so 2y will be equal to 0 plus 15. So 2y will be equals to 15. Y will be equals to 15 by 2. So the coordinates of the point P will be 0, 15, by 2, which means 7.5. Okay, 0, 7.5. Let me check that. The question number 5, the answer is 0, 7.5. So our answer to the question number 5, is correct. Okay. So here a curve was given. They asked us to find the equation of the normal at the point -1, 7. We derivated that. Then we put x equals to -1 in that derivative, the expression of the derivation. We found that the gradient of the tangent is -2. Then we found the gradient of the normal. We reciprocated that. We changed its sign. So the gradient of the normal is 1 by 2. Then we found the equation of the normal. Then their question was that when the normal cuts the y-axis, find the coordinates of that point. And he called that point P. So when the normal cuts the y-axis, x is equals to 0. So we just put x equals to 0 in that expression of the normal, and we found the value of the y, which was 15 by 2. So the P point is coordinates are 0, 15 by 2. So this is how you will find the gradient of, this is how you find the equation of the normal and the point when the normal cuts the y-axis. I hope that this question number 5 from the exercise 7C of the pure mathematics 1 is clear to you. Okay, so now we are going to the next question. The next question is question number 6. And let's do that question. Question number 6. Question number 6, we are going to attempt. This is exercise 7C, and it's question number 6 we are going to attempt. Okay, so the tangents to the curve y equals to 5 minus 3x minus x square at the point -1, 7 and -4, 1 meet at the point Q. Find the coordinates of the Q. Okay, so here question number 6, y is equals to 5 minus 3x minus x square. 5 minus 3x minus x square. This is the equation of the curve. We have to find the equation of the tangents at the point. There are 2 points given, one -1, 7, and another point is given -4, 1. So, we have to find the equation of the tangents at the point -1, 7 and at the point -4, 1. And then we have to find out the point of intersection of those two tangents. Okay, so this is the main question. So the method is very simple. First of all, I'm going to derivate this. So this will become dy by the dx equals to 5 derivative is 0 minus 3 minus 2x. So the dy by the dx will be equals to -3 minus 2x. Okay. Question number 6, we are doing 5 minus 3x minus x squared. Okay, so this is the derivative. Okay, so at the point -1, so at x equals to -1, the gradient will be, the value of the dy by dx will be -3 minus 2 into -1, and that will be -3 plus 2, that will be -1. Okay, the equation of the tangent at this point is y minus y1 equals to m into x minus x1. So y minus 7, that gradient is -1, x minus into -1. So this will be y minus 7 equals to -1 into x plus 1. So y minus 7 will be equals to minus x minus 1. So y will be equals to this -7 will go there, add, and it will become +6. Okay, so this is the equation of the tangent at the point -1, 7. So now at the point x equals to at x equals to minus 4, I will again find the gradient. So the formula is minus 3 minus 2 into minus 4, and this will become minus 3 plus 8. So it will become 5. The equation of the tangent, we have to find the equation of the tangent. So the formula is y minus y1 equals to m bracket x minus x1. Okay, so I'm going to find out the equation of the tangent here. So it will become y minus 1 equals to, the gradient is 5, x minus minus 4 bracket close bracket close. So y minus 1 will be equals to 5 bracket x plus 4, and y minus 1 will be equals to 5x plus 20. So y will be equals to 5x plus 21. So the gradient, the equation of the tangent at the point minus 1 comma, minus 4 comma 1 is y equals to 5x plus 21. And the equation of the tangent at the point minus 1 comma 7 is y is equals to minus x plus 6. In the statement of the question, they say those tangents meet at the point Q. Find the coordinates of the Q. So these two tangents, this one and this one, they meet at the point Q. So we have to find out the coordinates of that point. So if you want to find out the coordinates of that point, you will have to solve these two simultaneously. So what we will do, let me write those equations here. So now I'm going to find out the point of intersection of these two tangents. They intersect each other at the point Q. So the tangent number 1, its equation is y equals to minus x plus 6. And equation number 2, the tangent number 2 is y equals to 5x plus 21. So these are the two equations. I have to solve them simultaneously, and we will solve them. So these two are equals to y, so we will make them equals to each other. So it will become 5x plus 21 is equals to minus x plus 6. So this will become 5x plus x is equals to 6 minus 21. This is 6x equals to 21. 6 minus 21 is minus 15. Okay, so x will be equals to minus 15 divided by 6. So cut with the 3, so it will become, so the value of the x is minus 5 by 2. The value of the x is minus 5 by 2. Now I will find the value of the y. The value of the y will be, just put this value in any of these equations. So for example, y is equals to minus x plus 6. So y will be equals to minus into minus 5 by 2 plus 6, and plus 6. So this will become 5 by 2 plus 6. So when you take the LCM here, so this will become 5 plus 12. So it will be 17 by 2. So I think the point of intersection will be minus 5 by 2 comma 17 by 2. So these are the coordinates of, I hope this answer is right. This is the point Q. Okay. So this is 5 by 2 means minus 5 by 2 means let's check if the answers are right. They say the answer is minus 2.5 and 8.5. So our answers are right. Minus 5 by 2 means minus 2.5, 17 by 2 means 8.5. So this is how you will do the question number 6. The question was very simple. They gave you the equation of a curve, And then they said that at the point minus 1 comma 7 and at the point minus 4 comma 7 there are two tangents, and those two tangents intersect at the point Q. So you have to find out the point of intersection of those two tangents. You have to find out the coordinates of the point Q. So we found the equation of the one tangent, then we found the equation of the other tangent, then we solved both these equations simultaneously, and we found that the x value is minus 5 by 2 and the y value is 17 by 2. So that means the point Q, its coordinates are minus 5 by 2 comma 17 by 2. In your book the answer is minus 2.5 comma 8.5, which is the same if you write them in the decimal. So this is how you do question number 6 of the exercise 7C, which is from the Pure Mathematics 1. We are working on the solution of the course book, and these videos are basically for those students whose mathematics is little weaker. So they have to go through the course book. They have to do each and every question starting from the basic levels, and then the intermediate level, and then the advanced level. This is how those weak students learn the concept. So this is the idea behind doing each and every question from the course book. If you are very brilliant in mathematics, then you might not need that much practice. So, but the practice is the key to the success in the mathematics. So this was the question number 6. Now we are going to the next question, and the question number 7. So we are going now to the question number 7. Okay, let me erase this. Question number 7. Okay. So we are on the exercise 7C and going to attempt the question number 7. Exercise 7C is question number 7. The normal to the curve y equals to this is the equation of the curve y 4 minus 2 under root x. At the point is given 16 comma minus 4. The normal meets the x-axis it cut the x-axis at the point Q. So we have to find out the equation of the normal, and we have to find the coordinates of the Q. So they are talking basically about the normal. Okay, so they are talking about normal. Okay, so listen carefully to the question again, so that we want to make sure that each and every symbol I have noted down there is correct. The normal to the curve y equals to 4 minus 2 under root x at the point P, which is 16 comma minus 4. This point, its name is P point. Meet the x-axis at the point Q. Find the equation of the normal PQ. Okay, so first the first part is we have to find out the equation of the normal at the point P, and in the second part we have to find the coordinates of the Q, which is the point of intersection of that normal with the x-axis. Okay, so I hope that the statement is clear to you. So the method is very simple. I'm going to derivate it. So because I want to find out the normal, the equation of the normal at the point P. This is the point P. This is point P. Okay. So we will differentiate it. So dy by the dx will be equal to the derivative of the 4. But before taking the derivation, let me write it in the exponential form. Y is equals to 4 minus 2 into the x raised to power 1 by 2. Okay. So the y will be equal to derivative of 4 is 0. So dy by the dx will be equals to, this is 2. The 1 by 2 will come on the side x. When you decrease the 1 by 2 by 1, so it will become minus 1 by 2. Okay. So the dy by the dx will be equals to 2 to cancel. So minus 1 divided by the under root x. So this is the expression for the derivative. Okay, then what we will do, at the point at x equals to, the x value is 16. Let me check if this one, the 16 is correct. Yeah, 16 comma minus 4. Okay, so at x equals to 16, the value of the dy by the dx will be equals to minus 1 divided by the under root 16, that is minus 1 divided by the 4. So the gradient of the normal will be 4. You see, the gradient of the tangent is minus 1 by 4. So the gradient of the normal will be the reciprocal of it, and you change its sign. Then we have to find the equation of the normal. The equation of normal, so that is y minus y1 equals to m bracket x minus x1. So y minus minus 4, and that is equals to, the gradient is 4, x minus 16. So this is y plus 4 equals to 4x minus 64. So y will be equals to 4x. When it will go there, it will minus 68. So this is the equation of the normal. So this is what they asked us to find. So y equals to 4x minus 68. This is the equation of normal. This is the A part of that question, which is correct. Okay, so I have checked the answer from the book. Now we go to the B part. He says that normal cuts the x-axis. You see, when this normal will cut the x-axis, any line on any curve, when it cuts the x-axis, the value of the y at that point is 0. So when the normal cut x-axis, the y value will be 0. Okay, this is the rule. When the normal or any line or any curve will cut the x-axis, the value of the y will be 0. Okay, so what we will do, in the equation of the normal, which is y equals to 4x and minus 68, in the place of the y, I will put 0. So 0 is equals to 4x minus 68. So 68 is equals to the 4x. So the x will be equals to 68 divided by the 4. So x 4 ones are 4, 4 sevens are. So the coordinates of the point Q will be 17, 0. The coordinates of the point Q will be 17, 0. Let me check. The 17, 0 is the right answer, sir. So the coordinates of the point Q, this is the point where the normal cuts the x-axis. So the coordinates of that point Q are 17, 0. That was the B part of the question 7 of the exercise 7C from the Pure Mathematics 1. This is AS and A levels mathematics is paper 1. We are working on the course book. This is the topic of differentiation and its subtopic, the tangents and normals, equations of the tangents and equations of the normal. These videos are for weak students who need to work on the course book to master this concept. So this is how you do the question number 7. Let's go to the next question. The next question coming up on your screen is question number 8. Here, let me erase this. Now we are going to work on the question numbers 8 of the exercise 7C. Exercise 7C, question number 8. This is the second episode on exercise 7C. So you see, exercise 7C, we are going to work on the question number 8. Okay. Exercise 7C, question number 8. It says the equation of a curve is, the equation of the curve is given here, y is equals to 2x minus 10 divided by the x square plus 8. Their first question, the A part, there are two parts in it. And the equation of the curve is y equals to 2x minus 10 divided by x square plus 8. Their question is, A part is find dy by dx. Okay, this is their first part. They just want me to find out dy by dx. Okay, so let me simplify this. Y will be equals to 2x minus 10 x raised to power minus 2 plus 8. I just bring it upstairs. Okay, so then I will derivate it. So dy by the dx. 2x derivative is 2 minus 10 into minus 2 into x. I will decrease this power by 1, so it will become minus 3. 8 derivative is 0. So dy by the dx will become, this is 2 plus 20 divided by the x cube. So this is the A part. They asked us to find out the expression for the dy by dx. This is the A part of this question. Let me check from the book. It says 2 plus 20 divided by x cube. Oh, yes, the A part is correct. Okay, then the B part. Question number 8 is B part. He says, show that the normal to the curve at the point minus 4 comma minus 5 by 8 meets the y-axis at the point 0 comma minus 3. So we have to find out the normal. First of all, we have to find out the equation of the normal at the point. The point is given here, minus 4 comma minus 5 by 8. Minus 4 comma minus 5 by 8. So we have to find out the equation of the normal at the point minus 4 comma minus 5 by 8. Now I'm working on the B part. Okay, so first of all, we need to find out the gradient, minus 4 comma minus 5 by 8. So in the expression of the d, so at x equals to minus 4, the dy by the dx will be equals to 2 plus 20 divided by the value of the x is minus 4. So minus 4 and its cube. So the dy by the dx will be equals to 2 plus 20 divided by, this becomes 64. 4 4s are 16, 16 4s are 64, and that negative will come here. So dy by the dx will be equal to 2 minus, so cancel with the, this is 5 by 16, take the LCM. So dy by the dx will be equals to 16, this becomes 32 minus 5. So dy by dx will be equals to 32 minus 5, and that will be 27, I think. Yeah, 27 divided by 16. So let me check that calculation again. So we want to make sure that everything is good. So we put x equals to minus 4. This is 2 minus, and 20 divided by 64. And we cut it with the 4, so this is 5, this is 16, 16 to the 32, 32 minus 5 is 27, 27 by 16. So this is the gradient of that, this is the gradient of the gradient of that tangent. The gradient of the normal, will be equals to 16 by 27, put a negative sign with it, okay? Now, we will find the equation of that normal, because we know the gradient of the normal and we know the point at which the normal is touching that curve. So it is y minus y1 equals to m bracket x minus x1. Put those values here. I'm going to do it directly. So this will become plus 5 by 8. It's minus and this minus became positive. Just I want to make it simple. 27 into x. This is minus, so it will become plus 4. Okay. So you will have y equals to, so this is y 5 by 8 equals to minus 16x by 27 minus 64 divided by 27. So y will be equals to, this will become minus 16x divided by 27 and minus. This will go there, it will become minus, let me do it, okay. Minus 5 by 8, okay. So we can use calculator to find out the minus 64 divided by the 27 plus, sorry, minus 5 divided by 8. So that is equals to minus 647. The numbers are becoming huge. So we have to check again and again our calculations, so to make sure that we are not making any mistake. Okay. So let me check again. In the expression of the derivation, question number 8, to the curve at the point is, okay, minus 4 comma minus 5 by 8, minus 4 comma minus 5 by 8, we put it the minus 4 here, and its cube will be 4 4s are 16, 16 4s are 64, and this negative will come here. So here we have positive sign. Okay, so 32 minus 7 is 27. So 27 by 16, we reciprocated it, we changed the sign, that's the gradient of the normal, y minus y1. We put this value here, we put this value here. The gradient is minus 16 by, so this becomes minus 16x divided by 27, minus 64 divided by 27. This goes to the other side, and this becomes minus, okay. So the equation will become, it is y equals to minus 16x divided by 27 and minus 647 divided by 216. So this is the equation of the normal, and now they say that normal meets the y-axis at the point 0 comma minus 3. So you see, when the normal or any line or any curve cut the y-axis, the value of the x is equal to 0. Okay. So the y will be equals to minus 16, this is 0 divided by 27 minus 647 divided by 216. So y will be equals to, this becomes 0, this becomes minus, and this becomes they said that it will meet at 0 comma minus 3, but our answer is it's not coming. Let me check again, because I think we made some mistake. It is 2x minus 10 by x square plus 8. This is the equation of the curve, which is right. Find dy by dx. The expression for the dy by dx is 2 plus 20 divided by x cube. 2 plus 20 divided by x cube, that is right. And then we have to prove that the point of intersection will be 0 comma 3. Okay, So let me check again. I think there is some mistake here. So this is 2 plus 20 by x cube. So 2 plus 20 divided by, in the place of this x, I will put minus 4. The cube of the minus 4 will be 4 multiplied 4, 16. 16 multiplied 4 is 64. Okay. So due to that negative, I put negative here. So now 2 minus 20 divided by 64. So let me check on the calculator. 2 minus 20. 2 minus 20 divided by the 64. The answer is, this is 27 by 16. So this is the gradient of the gradient of the normal, the gradient of the tangent, sorry. The gradient of the normal will be reciprocal of this and sign change. So I changed its sign. I made it minus 16 by 27. So at this point, the equation of the normal will be y minus y1 equals to m bracket x minus x1. The point is minus 4 comma minus 5 by 8. Okay. So the x value is minus 5 by 8. So it will become plus 5 by 8 plus, this is the gradient, x minus minus plus 4. Okay. So y plus 5 by 8 is equals to minus 16x by 27 minus, when you take it inside, this will become 64 by 4, 16s are 64 divided by 27. So this is minus 16x divided by 27. This is minus 64 by 27. This will go there. It will also become negative. So I'm going to do the process with them. So minus 64 by 27 minus 5 by 8. So we think that is minus 64 divided by 27 minus 5 divided by 8, and the answer is minus 647 divided by 216. So when the normal cuts the question is, show the normal to the curve at the point minus 4 comma minus 5 meet the y-axis at the point 0 comma minus 3. Okay. If I divide 647 divided by 216, it is approximately 2.99. Okay. Sorry. You see what happened here? This thing becomes 0. This is 2.9953. So this is basically minus 2.9953, and the y is approximately minus 3. So that point is 0 comma minus 3. Because we have to prove that this is minus 3, but my answer was not coming minus 3. So I have to recheck this thing again and again, that if I had made some mistake. But actually what happens when you divide them, this is 2.9953. So 2.9953, when you round it off, it is approximately minus 3. So this is how you do the question number 8. And this is what we have to prove, that when the normal cuts the y-axis, it is 0 comma minus 3. You see, because of this calculation here, you see here, when I divided this, this is 2.9953, and the book says the answer should be minus 3. So this is basically, we round it off. So due to this, I have to recheck this calculation, that if we had made any mistake. So this is how you do the question number 8. This question is perfect now. There was no mistake at all in it. Just at the end, when I look at what we have to prove, that was minus 0 comma minus 3, but my answer was 0 comma minus 2.9953. When I converted them into decimal, then I realized that we can round it off. Okay. So this is how you do the question number exercise 7C, question number 8. In this exercise, you see, total there are 16 questions. And okay, let's do one more question, question number 9, and then we will uh, call it a day. Okay. So let's do the next question. The next question is exercise 7C, question number 8. Exercise 7C, question number 9 we will do. Question number 8 we are done. Okay. So for tomorrow we will have only 7 questions. But these questions are, there is a lot of calculation involved, and we have to be very, very careful that if we do that we do not make any mistake. You see, a very simple, even if you put a sign, if your sign goes wrong, then it's the whole question goes wrong. So we are on the question number 9. The normal to the curve. Here a curve is given, y is equal to 6 divided by, we have x minus 2 and a radical sign on it. It's a square root. The normal to the curve y equals to 6 divided by under root x minus 2 at the point. So they are talking about basically about the normal at the point 3 comma 6. It meets the x-axis at point P, and the y-axis at Q. We have to find out the midpoint. Their question is, what is the midpoint midpoint of PQ? This is their question. Okay. So basically, listen carefully. We are going to make sure that each and every symbol, the signs, they are perfect, correct. This is question number 9 from the exercise 7C, pure mathematics. 1. The normal to the curve y equals to 6 divided by x minus 1, and there is a square root on x minus 2. At the point 3 comma 6, I also noted down 3 comma 6, yes, meets the x-axis at P and y-axis at Q. Find the midpoint of the PQ. Okay, so we have to first of all find the equation of the normal at the point 3 comma 6. Then we will find the coordinates of the point P, and then we will find the coordinates of the point Q, and then we will find the midpoint of the PQ. Okay, so let's do it. And okay, so first of all, I'm going to bring this thing upstairs. So this will become 6x minus 2 raised to power minus 1 by 2. This is 1 by 2 when the power is 1 by 2. So when I bring it in the numerator, the power becomes negative. Then I'm going to derivate it directly. I'm going to derivate it. So dy by dx is 6 into minus 1 by 2. The power comes on the sign. The power is decreased by 1. Minus 1 by 2 minus 1. Minus 1 by 2 minus 1. So that will be minus 3 by 2. And then I will take the derivative of this base. That will be 1 minus 0. So the dy by the dx will become 3 negative divided by, this is x minus 2 raised to power 3 by 2. Okay. So when I derivated it, this is minus 3 divided by x minus 2 in the numerator and raised to power 3 by 2. Okay, at x equals to 3, so the dy by the dx will become minus 3 divided by the 3 minus 2 raised to power 3 by 2. So the dy by the dx will be equal to minus 3 divided by 1 raised to power 3 by 2. So the dy by the dx will be equal to 1, any power of the 1, the answer is 1. So the dy by dx is minus 3. Now the gradient of normal, the gradient of the normal will be the reciprocal of this and sign change. The equation of the normal will be y minus y1 equals to m bracket x minus x1. So we will find the equation of the normal here. The equation of the normal will be y minus 6 equals to 1 by 3 into x minus 3. Okay? Y minus 6 equals to, the m value is 1 by 3, and bracket goes. So you can do it like y minus 6 equals to, this becomes 1 by 3x minus 1. So y equals to 1 by 3x minus 1 plus 6. So y will be equal to 1 by 3x plus 5. Okay. Now the point P, this is the equation of the normal. The point P is when the normal cuts the, when the normal cut x-axis, the y will be 0. So 0 will be equal to x by 3 plus 5. So x by 3 will be equal to minus 5. So x will be equal to minus 15. So the point P will be minus 15 comma 0. Okay. Then they say when the normal cuts the y-axis. So when the normal cuts the y-axis, let me erase this. You see, when this normal, when the normal cut the y-axis, the x will be 0. Okay. So in the equation of the normal, which is y equals to 1 by 3x plus 5, in the place of x we will put 0. So the y will be equals to 5. The q point will be 0, 5. So we found the coordinates of the q also. The coordinates of the, now we know the coordinates of the P, we also know the coordinates of the Q, and the main question is find the midpoint of the PQ. So you remember the formula for the midpoint is x2 plus x1 divided by 2. The formula for the midpoint is midpoint of PQ. The formula is x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. So we have the value of the P here, which is minus 15 plus 0 divided by 2, comma, 0 plus 5 divided by 2. So it will be minus 15 by 2, comma 5 by 2. Your book sometimes write the answer like this, minus 7.5, comma 2.5. So I think the coordinates of the midpoint will be minus 7.5, comma 2.5. Let me check the answer. Question number 9 we are doing. Minus 7.5, comma 2.5 is the answer in the at the back of the book. So we are done with the question number 9, and this is how we do the question number 9. Curve was given, its curve's equation was given, and he says that a normal at the point 3, 6 cuts the x-axis at the point P and the y-axis at the point Q. Find the midpoint of the PQ. That is the question. So we derivated it. We put the x equals to 3 in that expression of the derivative. So we found that the dy by dx value is minus 3. That is the gradient for the tangent. The gradient of the normal will be 1 by 3. We found the coin of the normal. Then we found the point P when it cuts the, I think, y-axis, x is equals to 0. We found that sorry, for P, when it cuts the x-axis, y equals to 0, the P coordinates are minus 15 comma 0. In the same way, when it cuts the y-axis, x is equals to 0. So the Q coordinates are 0 comma 5. And then we found the midpoint of the PQ. So our answer is right. This is how we do the question number 9 of the exercise 7C. So I think that's it for today. And so this is, I'm in Sargodha right now, Ferhan Mazher. I live in Sargodha. And this is, it's hot and humid here. And today is 30, I think right now, the 31st, I think now it's 31st of August. And it's still hot and humid here. You see the programs we are doing, the live sessions we are doing. They are about the course book of your pure mathematics 1. And the basic theme of this live session is that we want to provide help to weak students who are in the A levels. Their best basic mathematics is weak and they need a lot of practice, and then they are able to master this concept. The brilliant students whose mathematical skills are very good, they can grasp the concept just by practicing the topicals. But the weak student, they struggle a lot. So the theme of this thing is that solve the course book provided by the Cambridge. I'm working on it. So every day I'm coming, I'm trying every day that I do. I give you 1 hour and I solve them. Sometimes you see what happens. We make mistakes because we are going live and there are a lot of calculations involved, and the space we have is a little smaller. So forget the mistakes. The doing mistake is not a problem. You see, the if you make a mistake, the important thing is that you go after that mistake and you learn from it, you correct it. So I hope that this video will be helpful to you. Please like this video. Please share this video. Please also subscribe to my channel. It supports my work. So thank you very much, everyone. Have a good night. God bless you all.